Hi, welcome to the course we call Prescriptive Business Analytics. That's kind of a mouthful, so let's use this introduction to describe what these terms actually mean and also to give you a little roadmap of the activities that are involved in actually doing this. The prescriptive word means that the objective of what we're doing is some sort of decision or recommendation for a decision. We're not doing analytics to gain information from data. That's another subject altogether. What we're trying to do here is to make a decision that gives us the best possible outcome based on what we know. The term business is pretty self-explanatory. We're going to limit our attention to business type problems, which usually involves money in some way or shape or form. And finally, analytics are the tools that we're going to use to arrive at a decision, and that implies that we're going to use quantitative analysis approaches to finding the best possible decision in a given situation. If we had to summarize this course in one word, we could call it optimization. In other words, take what we know and make the best possible decision on that basis. There are quite a lot of steps involved in getting from a business situation to an actual recommendation for action. So let's break the roadmap down a little bit. But before we do that, let's look at the reasons why we would use prescriptive analytics or quantitative analysis. The first thing you would look at is what are the alternatives to an analytical approach. And you'll find that many managers operate on gut feel, judgment based on experience, or what we call heuristics, some sort of rule of thumb that they've learned works okay and gets them close enough. These methods can work in a lot of situations. They do work in a lot of situations, and they work well enough for many purposes. But there are a number of situations where they don't work very well, and the main ones are problems that are too complex to yield to personal experience and judgment. In other words, it kind of overwhelms your ability to pick the pieces apart, and we need to quantify and analyze more systematically. It also applies in problems that are typically big dollar problems, where even a little bit of improvement can be worth an awful lot. So while rules of thumb may get you close enough, an analytical approach may get you that last few $1 million that may be worth the effort. New problems are similar to complex problems where you don't have any basis for judgment, don't have any experience to go on. Analytics can help there. And finally, one that we won't talk a lot about in this course, but is actually kind of important. A lot of problems are repetitive, and you want to be able to automate them in software. So things like inventory ordering rules that are embedded in ERP software use an analytical approach to get to a decision that's maybe not that complex, but it's something that you don't want to have to do manually every day. Okay, the roadmap here starts with what you're typically faced with in a business situation and ends with an actual decision or a recommendation for decision, since most of us are not usually the ultimate decision makers anyway. We start with what I'll call a situation, or perhaps might call it a mess. That's any kind of business setting where there's some sense that something should be improved or something needs to be done. From that, you need to extract the key elements of the problem and translate that situation into a problem statement. This is a very important step, and if you don't do that right, the rest of your effort is going to be wasted completely. We'll talk about each of these steps or translations in a little bit more detail on the following slides, but let's just go down through the roadmap here, remembering that we have to do things in this order, and we do have to do them right, because if you don't do them right, then what you wind up with at the end is pretty much worthless. Okay, we need to translate our situation into a problem statement. Once we've defined the problem that we're trying to solve, we need to create a quantitative model that represents that problem. That model can be in many forms. It can be pencil on paper, but to actually work with it, we're going to need to put it in some more usable form. So we need to translate our model into a spreadsheet model, which is a different skill set yet again, but it gives us a tool that we can communicate with and use to analyze the situation. Once we have a spreadsheet model, then we can do the analytics part. And this is where most of the emphasis usually comes in the description of what we're doing, but in some ways it's the least important part. It's really much more important that you frame the problem properly and set it up properly. Anyone can do the analysis once you've done that. The next step, once we've done some analysis, requires a little bit more judgment again. We need to learn something from that analysis. It's not usually sufficient just to come up with one number and say that's the best solution. You really need to understand the context of that solution and what risks and uncertainties lie around it. That's what I mean when I say insight. And once you're equipped with an actual analysis and some insight about what the situation is doing, then you can go ahead and make your decision. Let's look at each of these steps in a little bit more detail. A situation is typically an unstructured mess. It's a mixture of facts and opinions. Fortunately for you, most of the problems we give you in a business class are pretty well structured, and they don't need a lot of translation to get to a problem statement. Business situations are typically not well structured, and you really need to think about them fairly carefully before you go ahead and start addressing a problem. This allows us to avoid what we call type 3 errors, which is solving the wrong problem. A problem statement has three essential elements that you have to be able to articulate to say you've got it right. One is the goal that you're trying to accomplish, something quantifiable. Usually something like profit would be a good choice, but it's not always the one that you're concerned about. Second, you must define what things you're going to allow yourself to control in this situation. Yes, you can control lots of things, but the art of modeling and problem solving is picking the key items that are going to make the most difference, which means you have to understand something about the root causes of what's going on and what you're seeing. And finally, to have a complete problem statement, you need to be able to state the things that are in place that are going to limit your ability to make these choices. These are what we call the constraints. Once you have a reasonably well-defined problem statement with those three elements, we need to translate it into an actual mathematical model. And you notice the key elements of the model are very much the same as of the problem statement. We need decision variables, we need a goal. Now we need some data to do our calculations. And we need to include our constraints. But they are actually not part of the basic model. They're applied after the fact. So fundamentally, a model is a problem statement with equations linking all the moving parts. Your model is successful if you can change the decision variables and see the results on the goal. Putting a model into a spreadsheet should be pretty straightforward if you've done it well. If you're thinking ahead and you design it the right way, the translation should be fairly easy. But there are a number of skills involved in setting up good spreadsheets, and we'll try to teach some of those along the way here. They're kind of different skills, but they're strongly related. But you need to have stuff in a spreadsheet before we can do very much with it. Once you have your spreadsheet, we can do all kinds of analysis. Most typically, we're going to do some sort of optimization analysis to find the best possible outcome, but we're also going to do a number of sensitivity analyses to find out what happens if typically certain parameters change or anything else that could be uncertain in the world. We can plug that in and see what happens so that we really understand the full scope of what we're trying to determine. That would also help identify things out there in the world that are important to us that we need to pay attention to. As I said before, doing the analysis can be fairly mechanistic and doesn't necessarily give you a lot of insight unless you think about what it is you're doing. So while we're doing analysis, we need to be getting an understanding of what's really going on so that we can really frame the recommendation in an appropriate context and say, yes, this is the decision you would make under these set of circumstances, but be aware that it could change if something out there in the world changes. Things like risk come into play, something we won't talk about right away, but we'll deal with later in the course. All of this is aimed at providing a decision or a recommendation that is intelligent and insightful, not just a simple mechanistic calculation. Finally, once you have the insight needed to make an intelligent decision, you typically have to communicate that to somebody else. Unless you're running your own business and you're the ultimate decision maker, you're going to have to convince other people that you've done the right analysis and that your decision is the right one. So if you've done the analysis properly, that will provide you with the quantitative backup. It'll provide you with the graphical outputs that show the sensitivity analyses that you've done. All of these provide credibility and support to the decision or recommendation that you're about to make. Okay, that's our roadmap. That's what we're going to do in this course. And we're going to spend quite a lot of time talking about each of these individual parts, but this will give you a framework for where we're going. And you need to recognize that all of these pieces are important. They all have to be done in the right order, and a failure at any stage is going to result in a decision or recommendation that is either wrong or is not going to be credible and accepted by your audience. The next item in this series, next video I'll put together, will deal with the complexities of developing problem statements from a messy business situation and using the tool that we call an influence diagram. That will lead us naturally into model development, so that the two are kind of linked at that stage. And that will be the next presentation in this series. Thanks for listening so far. Hope you stay with us.